In today's lesson, we're going to take a look at how to find missing lengths in oblique triangles, so triangles that are no longer right triangles. And up until now, that's nothing that we've ever been able to do. So we can do that using the law of sines and law of cosines. Today specifically, we're going to look at a few examples using the law of sines. And the law of sines simply allows us to take oblique triangles and solve for missing, just like we were doing with right triangles, but now we're no longer bound by triangles needing to be right. And it uses a ratio that happen to be proportional. So in order to set these up, we would take the sine of angle A over the side opposite it, lowercase a, and that ratio is proportional to the sine of angle B over side length B, and sine of angle C over side C. And so there's a few different scenarios that will take place. I can have two angles and the included side, that's ASA, two angles and then the non-included side, that would be AAS. And in both of these examples, there will be one solution when I have two angles and one side. Doesn't matter how that's arranged. Next thing that happens is there is what's called the ambiguous case, and that occurs when you have two sides and a non-included angle. So when I have two sides and a non-included angle, sorry, this should actually be SSA or ASS. It's called the ambiguous case, and we'll take a little look at why that term is used. But first, let's do some examples using our angle side angle. So in this case, I have two angles and one side. So knowing triangle sum, I know that 108 plus 23, the interior of every triangle, will always sum to 180. So I have 131 degrees already. I take that away from 180. And I get 49. So I have my three angles. Now let's find the side lengths. Well, this is angle A, so this would be side A across from it. This is C, so this would be side C. This is angle B, so this would be side B. So let's start with finding A. Well, using our ratios, what we can do is we can set up a proportion. So I know that the sine of angle A over length A is equal to, now notice I've already got an unknown quantity right here, so I need to build the full ratio on this one in order to set this proportion so that I can actually solve it. So I'm going to use this side C because I know that side length and I know that this angle is 49. So I'm going to say the sine of 49 degrees over 7.7. Now, how do we solve proportions? We just cross multiply. So I have 7.7 times the sine of 23 degrees is equal to A times the sine of 49. Now in order to solve for A, I'd go ahead and divide. So I divide both sides by the sine of 49. So in this case, this is equal to 7.7 times the sine of 23 over the sine of 49. And we'll just go ahead and put that in our calculator. So I'm going to go to mode. I'm going to double check and make sure, see it defaulted back to radians. So I'm going to plug in degrees. And I'm going to go ahead and just put this in as a stacked fraction. Make it look exactly like this. So I have 7.7 times the sine of 23 over the sine of 49. And I get 3.98. And we're going to go ahead and round that 3.99. So there is side A. And we're going to do the same thing here, but now we're going to find side B. And so in this case, since this was the given information, I'm going to go ahead and leave that the same. So I'm just going to go ahead and get rid of this and that. And we'll just plug in the new information. So in this case, that's the sine of 108 degrees over side B. And it solves in the same manner. Cross multiply. And then we divide. Now what I can do is I can just go ahead and go back up here, and I can say second entry, second enter, and I'll just go back in and I'm going to edit these. And you see the only thing that's changed then is the 108. In this one I get 9.7. Now if we do a little mental check, we should remember there's a relationship here, triangle inequality, that basically says that the largest angle is opposite the longest side, and the smallest angle is across from the smallest side. And we see that that does certainly hold true in this triangle, so it would appear as though we've done that correctly. So just a little quick mental check to make sure that our answers seem reasonable or that they make sense. Let's take a look at another case. So if this is angle A, we're going to call this side A. This is angle B, so we're going to call this side B. C, so this is side C. So again, triangle sum theorem says that all the interior angles of any triangle will add to 180 degrees. So that's 131 plus 11. Leaves me at 142. So this angle then is going to be 38 degrees. So now we set up our ratios. I'm going to go ahead and leave this one in first because I know side C and angle C. I'm going to say the sine of 11 degrees compared to the length of the side, 0.65 miles, is equal to, we'll find A first, the sine of 131 over A. We cross multiply. So I have A times the sine of 11 equals 0.65 times the sine of 131. I divide, and A equals 0.65 times the sine of 131 over the sine of 11. So we'll go ahead and punch that in. Alpha y equals will give us that stacked fraction, and I put in 0.65 times the sine of 131 over the sine of 11. And I get 2.57. This would be miles. And then we'll do the same thing here, but we're just going to change the value, or this ratio here, sine of 131 to A. This is going to become the sine of 38 degrees to side B. So that really just filters on down and changes. So this one would be B. And you make those same changes in your equation. It's going to be solved the exact same way because this ratio becomes proportional when they're set equal, and we just cross multiply to solve that. So again, I'll go second, enter. Takes me right back here. And again, the only change is this angle. So I'm going to go ahead and just change that to 38 degrees. And that's 2.097. We're going to round that to 2.1. And again, we do a quick mental check to make sure. Smallest, smallest, biggest, biggest. Looks good. Now let's talk a brief moment about that ambiguous case, case they call ambiguous. And here's why they use that term. When I have two sides in the non-included angle, a couple things could happen. So if we set up the triangle in the same manner each time, we can take a look at a couple things. So think of this in terms of a right triangle. That's why we drop this down, this altitude, because if this were a right triangle, this would be equivalent to B times the sine of angle A. Because in order to find this from A, I would have taken from here the opposite over the hypotenuse. So that would have been this value over the hypotenuse. That is the sine ratio. So the sine of the angle equals the opposite over hypotenuse. When you rearrange that, you get the hypotenuse times the sine of the angle. That would find you the unknown here. So this is b times the sine of a. What that allows us to do is to build this triangle to see, well, if I have these pieces of information, if I have angle A and then I have side A and B, well, a couple things have to occur. If A, the side length of A is greater than B, you see what happens here, it will intersect it exactly once. It might be somewhere down here, it might be somewhere here, but this arc is only going to intercept side, this would be like side C, only at one place. So if the A value is greater, so if the angle or the side length opposite the angle you have is greater than the other, you're going to have one potential solution. If A is equal to B times the sine of A, what you actually have is a right triangle. It will only intercept it once, and this is actually a right triangle. So you see that arc here with this side length. If A is less than this altitude, so if it's less than B times the sine of A, you see what happens here is it will not even, doesn't even extend far enough to even intersect this third side. So this arc right here represents this side A swinging, and it will not even intercept to create a triangle. So if this value is less than B sine A, you actually have no solution. And in this scenario, if B is greater than B sine A, so it's longer than this altitude but less than the side length of B, you have this, if it were on as a pendulum, it would swing like this, would actually intercept the third side potentially in two locations. So you'll have to check them both and look at the angle measures to see which of those makes sense with respect to the triangle, because it could intercept it here or it could intercept it here, which essentially is either going to make it an acute triangle or an obtuse triangle. So it's going to be one or the other depending upon where this intercepts. And we'll explore this situation of the ambiguous case a little bit more in class. But let's take a look at this scenario. And what's usually easiest to do is to go ahead and build a triangle. So we're going to go ahead and create a triangle here. We're going to label this ABC. And actually the way you see it in the scenarios up above, they typically go this way. So this would be side length B, this would be A, this would be C. Doesn't make any difference, but it just orients your triangle a little differently. So if we know that angle A is 25 degrees, side length A is 13, and B is 12. What we have right now is that A, this side across from the reference angle that they have, so the side across from the angle given, is more than the other side, more than B. So this is actually going to have one case, one situation, or one point of interception, and it's actually going to look probably something similar to this. So if we go back up there, this would be when A is greater than B, and it is this scenario right here. A is longer than the side length B, so it will intercept it exactly once. So again, to set this up, we do the same things. So I'm going to say the sine of 25 degrees compared to 13 is equal to, we'll say in this case, the sine of B over 12. So you see the information missing is a little bit different now. Now we're trying to solve for B here instead of a side length. So we still cross multiply, and I get 12 times the sine of 25 degrees is equal to 13 times the sine of B. Now, in order to solve this, I'm going to have to use those inverse functions again, the arc sine. So I'm going to divide both sides by 13. That'll cancel there. So that gets me this value, 12 times the sine of 25 over 13 equals, and now we're just to the sine of B. And how do we undo that? Well, in this case, I'm going to take the arc sine, or the inverse. So those would cancel, and I'll do the same thing over here. And so B equals the arcsine or inverse of 12 times the sine of 25 over 13. And we'll put this into our calculator. Okay, so we'll put that in, and we'll take the inverse sine of 12 times the sine of 25 degrees over 13. And we have 22.96. So what we just found was angle B. So 22.96. So now what we can do is we can find C, because I know that 180 minus 22.96, we can certainly round that to 23, and I get 132.04. I'm going to change that to 132, and we'll round this one up to 23. And now what I can do is go ahead and set up a remaining ratio. So let's find side C. Well, same thing. I'm just going to use the same ratio here. Sine of 25 is to 13 as the sine of 132 is to C. We cross multiply. 13 times the sine of 132 equals C times the sine of 25. We divide, and I get C equals 13 times the sine of 132 over the sine of 25. So we'll put that in here. 13 times the sine of 132 over the sine of 25. And I get 22.859, so we'll say 22.86. And again, that certainly appears to make sense. Smallest angle, smallest side, largest angle, longest side. And let's look at one more. So again, first thing I really need to check. So I've got a side, and an angle. Let's build this triangle. Make it look like this. We'll call this angle A. It's 125 degrees, so I drew it obtuse. Side A is 35. Side B is 32. Okay, so we built the triangle. Now I'm just going to go ahead and set up the ratios again. So I have the sine of 125 is to the side length 35 as the sine of B is to the length of side B. So we'll cross multiply. And then we're going to go ahead and divide. So we'll divide both sides. So I get 32 times the sine of 125 over 35 equals the sine of B. And I'm going to take the inverse sine of this entire quantity, 32 sine 125 over 35 equals angle B. We'll go ahead and put this in the calculator. Let's start out here. We're going to take the inverse sine and have 32 times the sine of 125 over 35. And I get approximately 48.498. We're going to round that to 48.50. And let's go ahead and find, sorry, it's not the side length, that is angle B. Now I can find the other missing angle, 180 minus 48.5 minus 125. So this angle is 6.5. Now we'll set up and we'll find the remaining ratios. So let's do a similar thing over here. I'll take the sine of 125 over 35 is equal to the sine of 6.5 over c. Cross multiply. C times the sine of 125 equals 35 times the sine of 6.5. Divide by sine 125. And we'll get C is equal to 35 times the sine of 6.5 degrees over the sine of 125. And we get approximately 4.83. And we'll round that 4.84. And looking around, that makes sense. Largest side, largest angle. The next, smallest, smallest. Okay, let's look at another. Okay, so in this situation, let's double check. Let's build our triangle. I have angle A is 25 degrees, side A is 5, side B is 10. So here's A. Now, first thing I want to do is I want to check these and see clearly it's less than. So in this case, now I need it to be more than B sine A. So that would be 10 times the sine of 25. So let's look at that. And that is 4.22. So it is more than that. So what we just checked was think about this. If this were a right triangle here, so this was A, C, we'll call this one B now. So I'm just dealing with this part right here. This was 25 degrees. This is 10. This is our unknown side. We're going to call it A. So think about our standard right triangle trigonometry. I would take the opposite over the hypotenuse. That's the sine. So in this case, the sine of 25 equals the opposite side over the hypotenuse. Now, how do we solve for A? Well, I just multiply everything by 10. So A is equal to 10 times the sine of 25. And that's where that's coming from. Because if it's not greater than this, see, if this were on a pendulum, this length here, and this swung back and forth, this would hit it exactly once at a 90-degree angle right here. Anything shorter than this, and this would just swing, and it would never intersect this third side. So that's what we're checking when we verify when it's less than B, that it's still greater than B sine A. And that's where that's coming from. So if we go back up real quick, understand that we fell into this category right here. It's greater than B sine A, but it's less than B. So there's two potential situations. So we're going to solve for them both. Okay. So that didn't work out very well. Okay, so let's go ahead and set up these ratios. So I have the sine of 25 degrees over 5 is equal to the sine of B over 10. Cross multiply. 10 sine 25 equals 5 sine of B. Divide. And I'm going to go ahead and start, because there's going to be a lot of work on this one, doing a couple different steps. I'm going to divide by 5, and I'm going to also take the arc sine. So I have sine to the negative 1 of 10 sine 25 over 5. So I divided both sides by the 5 and then took the inverse sine. And that's going to solve for b. So we'll pull that up in the calculator here. So I'm going to say the inverse sine of 10 sine 25 over 5 equals 57. We're going to call that 57.7. Sorry, not 75, 57.7. And then because this is the ambiguous case, it could intercept here, or it could come back and intercept someplace probably right about here. See if it were on this arc. There's once and twice. It would also be this angle's complement. So that's 180. Excuse me, the angle's supplement. Minus 57.7. It could also be 122.3. So I'm going to go ahead and write that in here too. 122.3, which is going to give us two potential values for this angle. So we also have 180 minus the 25 degrees, and then I'm either subtracting 122.3, so in that case, 155, this is either 32.7, so I'll keep that in red, or if this angle was 57.7, could also be 97.3. So it's one of these two, I don't know which. So let's go ahead and find the missing side lengths, depending upon which angle this is. And what I can do, since I found B here, I can verify which one of these it's going to be. I can do that essentially by using this ratio here, because it had better be the same. So if I know that the sine of 25 over 5 needs to be equal to the sine of b over 10, well, let's look. And you see that's the same. That's why this is the ambiguous case here, and there are two potential solutions. So it doesn't matter which of these it is, this ratio is still proportional to this ratio. So let's continue on and find the missing side length, or the potential side lengths for C. So again, I have the sine of, switch colors here, sine of 25 degrees over 5. I'm going to continue to use that because that was the given information. And I'm going to compare that to the sine of, well, we're in red, so we'll start with the 32.7 compared to C. Cross multiply. Sorry. And then we will divide. So C equals 5 times the sine of 32.7 over sine of 25. So let's go ahead and set that one up. And that's, let's see, 5 times the sine, 32.7. over sine of 25. So that would be 6.391. So there's one. And then we'll go back to blue. Clean this part up. And if this was 97.3, then I have the sine of 25 to 5 is equal to the sine of 97.3 over c, cross multiply. C times the sine of 25 equals 5 times the sine of 97.3, divide. And we get 5 sine 97.3 over the sine of 25. That would be 11.74. So there are the two potential side lengths, and we really don't know which one it is. See, the ratios still hold true, as I showed you on the calculator a couple minutes ago. If you also look at the side lengths, if this is the smallest angle, this is the smallest side, and you see it is still smaller than that, even if this is 32.7. If this were the largest angle, then that would be the largest side. This would be next, then that would be the last. If this were the middle, then that would be 10, and this would be the largest, and that would be 11.74. So again, we don't know which the true lengths are or the true angle measures. So in this case, there are two potential answers. And we're going to go ahead and leave it at that. We'll do a story problem practice in class, and if you have any questions, bring class with you and we'll get a little more practice.